Hello students, in this video I'll walk you through this presentation of heating curves and phase diagrams so you can complete your guides at home. Okay, so let's begin with heating curves. So heating curves are basically graphic representations that show us the changes of state of matter of a substance. In this case, we're gonna see the one of water. So we're gonna have temperature here on the y-axis and the amount of heat added in the x-axis. So as you can see, there are two horizontal lines that are called plateaus that correspond to the changes of phase. So this one here at 0 degrees Celsius, it's gonna be the phase change from solid to liquid. So below this point, water is gonna be solid. As we add energy, the molecules would start moving more. We're gonna say it's gonna have kinetic energy. When it reaches this point, the heat that we add is gonna be breaking the bonds of the water molecules. That is why the temperature remains constant. And after all the solids melt, we're gonna pass to this point where the water is liquid. And it will keep on rising, okay, kinetic energy again, until we reach the boiling point where we're gonna have water in both liquid and gas state. So here we're gonna say that the energy is not kinetic, molecules are not moving. We're gonna say it's a potential energy. That is an energy that can become kinetic again after all the liquid evaporates. Okay, here in this link you can see a simulation that shows what happens to the molecules, so I suggest that you go there. Okay, so well, these kind of curves allow us to see the state of matter of a substance in certain temperature. So you can know that, for example, at 40 degrees, water is going to be liquid, and that at 0 degrees, it's going to be both liquid and solid. For the grades that already took the lab, you're going to notice that your results were very similar to this, but we didn't reach this plateau at 100 degrees Celsius, but it was below, like around 92. So why does this happen? This happens because temperature is not the only factor that affects the phase changes. Okay, so we're gonna see that pressure affects this as well. And the pressure changes with the height above sea level. So if you are in the sea level, you have more air on top of you, so you're gonna have a higher pressure. So that would be, for example, in Cartagena, we would have a pressure of 1 atmosphere. In Bogota, that is up to 2,600 meters, that pressure is gonna be a little bit lower, and the boiling point is gonna be lower as well. Okay, so when we're talking about pressure and temperature, we get to the next concept, that is phase diagrams. So these phase diagrams are going to be graphic representations where we are going to have the phase changes, but not only according to temperature, but to pressure as well. Okay, so here you can see that, for example, from this point to this point, we have a separation between the solid and the gas state of matter. From this point to this point is the separation between solid and liquid, and from this point to this point, we're gonna have the separation between liquid and gas. There are two very interesting points that are the critical point and the triple point. So the triple point is gonna be the point of temperature and pressure where a substance can be in the three states of matter. Okay, so I leave you a link there where you can check how this looks. And the other point is the critical point, that is the highest point at which the temperature and pressure can allow a substance to be liquid or gas. If you keep on raising, it will only be gas, it will not be able to exist as a liquid. Okay, so let's see some examples of this. That is what you will have to answer in your guides. So here we have the phase diagrams for CO2, carbon dioxide, and for water. Okay, so as you can see, down here we have the temperature. In this case, it's not in Celsius degrees, it's in Kelvin degrees. So to convert from Kelvin to Celsius, it's very easy. You only have to subtract 273.15. So for example, if you have 273.15 degrees Kelvin, that would be 0 degrees Celsius. If you had 373.15 degrees Kelvin, it would be 100 degrees Celsius. Okay, so that you have that into account for your guide. And here we have the pressure in atmosphere. So 1 atmosphere would be the pressure at sea level. Okay, and well, in this case, we can go below to 0.06 and up to 218 atmospheres. Okay, so let's take a look here. For example, the triple point of water, we're gonna find it in this very low pressure, okay, of 0.06 atmospheres and at a temperature of 273.2 degrees Kelvin, okay, so that would be very close to 0 degrees Celsius. And the critical point would be at a much higher pressure of 218 atmospheres and a much higher temperature of 647 degrees Kelvin. Okay, so this graph allows us to see the state of any substance in any conditions of pressure and temperature. So for example, if I ask you which would be the state of matter for water at 218 atmospheres and a temperature of 0 degrees Celsius, well, you go here and you will find it's solid. If it's the same pressure but at 373 degrees Kelvin, now we will pass to liquid, okay? So in this pressure, we can pass only one phase change. It can only change from solid to liquid. And the only point it would change from solid to gas would be down here or below 0.06. Okay, in the CO2, we're gonna see that the diagram, well, looks similar, but we have lower temperatures here that change, and also the pressures where it changes are gonna be lower. So if you see in 1 atmosphere, we have the phase change from solid to gas. That is why when we take dry ice, that is CO2, it passes directly from the solid to the gas state. Okay, so also, well, here, if we take, for example, a pressure of 10 atmospheres, we're gonna have, in this case, 2 phase changes. We're gonna have from solid to liquid and from liquid to gas. Okay, so as I told you, the one of water, we saw that it needed more temperature to change of state, for example, compared to the one of CO2, and we're gonna see why that happens. That happens basically because the molecules of water have a special type of bonds, okay, that is what we said about the intermolecular forces, that are called hydrogen bonds. Okay, so these are going to be bonds that join together water molecules. So if we take this as a water molecule, well, we're going to see that due to the charge of electrons, the oxygen will be a little bit negative and the part of the hydrogen would be a little bit positive. So when we have several molecules of water, the negative part of the oxygen will attract with the positive part of the hydrogen. This bond is not as strong as the ones holding together the oxygen and the hydrogen in the molecule, but it's going to give the water certain properties like a high boiling point and a high melting point. Okay, so This part you can see it in more detail here in this link on the video. Okay, so that's pretty much it. Any questions, you can write me a mail and I'll be happy to help.